Welcome grade 8. In this video we are going to be stepping through the exercise 7.3 practice questions. This is an optional video, but if you are stuck on any of these particular questions, hopefully this helps in coming up with the answer or in explaining how to get to the correct answer. So in these questions, in the first questions, we are dealing with parallelograms, and we are asked to use our knowledge about parallelograms and angles in order to solve for either missing side lengths or missing angles in a particular question. So 1A, we have a particular parallelogram here. We are told that we have a side length here of 10. We have a side length up top of 2x. We have an angle here of 72 degrees and an angle here of y degrees. We have to figure out x and y. So let's start with x. So if this side length is 10, in a parallelogram, this side length has to be the exact same length. So this is 10, this is 2x. So in other words, 10 has to equal 2x. I could think about what do I have to times 2 to get to 10, or just divide both sides by 2. And I figure out that my missing value there, 10 divided by 2, is 5. So my x value is 5. That's for the side length. Now for my angles here, in a parallelogram, angles that are opposite to each other are always the same. So these two are going to be the same, and these two are going to be the same. So if this is 72, then that means that angle y also equals 72 degrees. B. Let's get to parallelogram B. In this one, we have one that looks a little bit more like a rhombus here, but here's our parallelogram, and we have lines going through the middle. We're told that this is 15, that this is 3x, that this is 12, and that this is 4y. Now the thing about these lines is that this distance and this distance are going to be the same. This is exactly the middle way. So this and this are equal. So in other words, 3x equals 15. Divide by 3, and I figure out that my first x here is 5, so that these two are both equal to 15. Here, 4y equals 12. Divide by 4, to figure out that my y here equals 3, so that my side lengths can now be equal or can be the same. C. C, I have a parallelogram. Let's draw what we know. We have kind of a line going through here as well. We know that this is 54 degrees. We know that this is 59 degrees. We are asked to figure out this, our y, and our x. So our x should be pretty easy. If this is 54, this is the opposite corner to that in our parallelogram. So x automatically has to be the same, or 54 degrees. Now our y, this is where it gets a little bit trickier. Here we have a different triangle here. Remember that in a triangle, all angles add up to 180 degrees. So I know this is 54, I know this is 59, I don't know why. So if I take 180 minus 54 minus 59, that's going to give me whatever is left, or that's going to give me my angle y. And if I plug all of that into my calculator, I'd figure out that angle y then has to be 67 degrees. So these are some of our values as we've gone through so far. Now in this particular question, it does give you D if you'd like to try, or for D, we have a similar question to C. Let's draw it and see if we can figure it out though. D, we have sort of a parallelogram here, and then we have kind of a triangle beside it. We're told that this is what our y that we have to figure out, this is our x that we have to figure out, and this is 126. Again, opposite angles here. If this is 126, then x has to be 126 degrees. Y is our next piece to figure out. If this is 126, then this has to be 180. So 180 degrees minus 126 degrees is going to give us 54 degrees. So that's this angle here. because this symbol is here, this symbol is a right angle, so that's 90 degrees. So I have 90 and 54. I have to figure out y. So 180 degrees minus 54 degrees minus 90 degrees gives us our missing value, which is going to be our y value, which when we plug that in is going to be 36 degrees. So that would be how we would solve. That's our y now. Y equals 36 degrees. The x and the y for that particular shape, for that particular parallelogram. Next, we're moving on to rectangles and using some of the information to solve for the missing angles or side lengths within rectangles. So we just have two here. In 2a, we have our rectangle with a diagonal line going through. We're told that this is 36 degrees, and we're asked to figure out our x as well as our y. Okay, so if this is 36, together that makes a corner of 90 degrees. So if this is 36, then our x just has to be 90 degrees minus 36 degrees, which is going to end up being 54 degrees. So our x equals 54 degrees. Our y, there's two ways we could solve it. We could either say, okay, this triangle is 180, so 90 and 54 are the angles, and take 180 and minus those to get y. Or we can use our z pattern to figure out that y has to be the same as this 36. Right? They're both interior angles in that z pattern that we've talked about before. So y equals 36 degrees in this question. So just some tricks that can help us solve some questions a little bit quicker than others. B. In this one, we are dealing with side lengths instead. So we have our rectangle. Again, we have our lines coming across. Mine are maybe not as straight as they should be, but they're straight in the examples that you're given. This is 18, this is 3y, and this is x. Because this is a rectangle, all these lines should be the same length. So if this is 18, then x also has to equal 18, which means that 3y also has to equal 18. Divide both sides by 3, and you figure out that y has to now equal 6. So we now have our answer for x and our answer for y using that rectangle. All right, let's move over to question 3. We're whipping through some of these, but question 3 gives us a rhombus. And a rhombus is just a square, but maybe slightly tilted. So the side lengths are all going to be the same length, but the angles are not going to be 90 degrees. So 3a, we are given what actually looks kind of like a square, but we don't know for sure that it's a square. It kind of looks more like a diamond. We're given side lengths 3x, 24, and 2y minus 6. Because all the side lengths are going to be the same length, we know that they all have to equal 24. So the first one, 3x equals 24, divide by 3, and I figure out that x has to be 8. For this one here, 2y minus 6 also has to equal 24. Start by adding 6 to both sides to eliminate that part. 2y equals 24 plus 6, or 30. Divide by 2, and y has to equal 15. So that would be how we would solve the missing side lengths in that particular rhombus. In B, we're given a rhombus that is much more on its side this time. And so it kind of looks a little bit like a parallelogram, but remember the side lengths are the exact same. It has a line going through again. We are given, this is 23 degrees. We do not know this, that's our x, and we do not know this one, that's our y, for the angles here. So something to note is that for this particular question, when we're looking for angle x is actually this whole angle and not just this little piece. If it was just the little piece, it would be 23. But we have two of those little pieces, so x actually equals 2 times 23, because they're going to be exactly the same. It's a rhombus, and so that line exactly splits the middle. So x has to equal 46 degrees here. if this is 23 and this is 23, that's 46 degrees. Y has to be what's left in the triangle. So 180 degrees minus 46 degrees, or minus 23 and 23, is going to give us our angle Y. And when we subtract those from one another, we get an angle Y of 134 degrees. So that's how we would solve those particular questions with the rhombus. Now let's move on to our last sets of questions, which deals with squares, finding the x and y values within those. So question 4, we have two pieces here as well. We have part A, which is a little bit easier, and part B, which is definitely not easy. Part A, there's our square. Again, we have lines going through, and we see that this side length is 17, so we have to figure out a side length. This one is 3y plus 2, but we also have to figure out an angle, and that one's this one right here, just angle x. We don't know what that is. So it's a square. We can start with angle x. We know that all of these angles together have to equal 360 because it's a full circle. We can do 360 divided by 4, which would tell us that angle x has to be 90 degrees. It's an exact square. This would be 90, this would be 90, this would be 90, this would be 90. So that one's 90 degrees because it's 1/4 of a full circle of 360. There's other methods you can solve it, but hopefully that one's a little bit easier. We know for y that this side length has to be the same as this side length. So 3y plus 2 equals 17. Let's minus 2 from both sides to start. So 3y equals 17 minus 2, or 15. Divide by 3 on both sides to get that y by itself. Y equals 15 divided by 3, or 5. So now you have your values for both x as well as for y. B gets much more challenging because our lines do not go straight through the middle. They do on this angle here, but on this one they go at a little bit of an odd angle, and so it's going to mess up all of our other angles here. We're told that this is 125 degrees, and we're asked to figure out the rest. So first of all, this is x. Sorry, we're asked to figure out this x and this y. So for this x, let's just ignore the 125 for now. We have a line going straight from corner to corner in a square. So what that would mean is that this is 90 degrees. X splits that exactly in half. So x equals that 90 degrees divided by 2, because I have two sides to this, or 45 degrees. So that's our first bit. Next we have to figure out y. Now y is a little bit tricky. To figure out y, I want to actually figure out this angle first. To figure out this angle, I have to figure out this angle first. I already know this is 45. This one is just going to be a straight line would be 180. I already have 125. So 180 minus 125 would mean that this angle here is going to be 55 degrees. Okay, so I know that this is 45 and this is 55. So 45 plus 55 is going to be 100 degrees, which means that this has to be whatever is left. 180 degrees minus 100 degrees equals 80 degrees here. And this y, being the opposite angle to that, is the same. So y equals 80 degrees. I know it was maybe a longer, more complicated way to get there, but that's how we can piece together what we know based on little bits of information and just start chipping away until we get closer and closer, in this case, to that y value. Hopefully that helps you as you step through these particular practice questions.